Hello and welcome, and this is Peter Nolan. Thank you very much for being with us today. I really appreciate you, so thank you for being here. Today's little video is actually a bit of a salesy video, okay? And the topic of today's little salesy video is what are the productivity, reliability, and stability benefits of using SeETL on a data warehousing project, right? What are the relative productivity profiles, okay? So I'm just going to talk about that and give some examples of that so that you can gain an understanding of, why do I think SeETL is a good idea? I mean, obviously I think SeETL is a good idea because I wrote it and I use it every day, okay? So SeETL was the software that I wrote for myself to use on data warehousing projects, and I use it every day. So obviously I'm eating my own dog food in that case, right? So let's just talk about the current productivity profiles, okay? Because the history of it is, well, all very nice to know. Doesn't tell you, it tells you how it evolved, but it's kind of a long story. You can go see it in the history of SeETL video, which will be on this channel. But the current productivity profiles, right? So there's two ways that SeETL can be run as an ETL subsystem. First, there's the old C++ engine, which personally I prefer. I'm building another product, or we're building another product, which will be a NAV data warehouse, and because NAV, this is Microsoft's NAV ERP, NAV has got a lot of tables and a lot of columns, and I did like a 1 week study on NAV about whether we should use the SQL generation version or the C++ engine version for building the ETL subsystem, right? And I went and tested a lot of different things. And after spending nearly a week on this, the answer came back, not surprisingly to me, that the build cost of using the older C++ version would be about 50% of the build cost of using the SQL version, right? So there are two versions of SeETL for use. One, the C++ version, and one being the SQL generation version. And the productivity profile of using the C++ version is about double, as in twice as productive, as using the SQL version. Okay? So I just want to say that up front. So as I compare things, you need to remember, I'm going to compare things talking about the C++ version. And you need to remember that when I'm talking about the productivity profile of using the C++ version, the SQL generation version is only about half that. Okay. Overall, the entire project, the SQL version, if you build data warehouses the way that I build them, you're only at about half the level of productivity as using the C++ engine. But of course, some customers will say, well, I've got the SQL in front of me. It's generated out of the design time tool, and I've got the SQL in front of me, and I know this is what I'm running, and I don't have to kind of rely on a piece of C++ that I don't have the source code for, because I've been selling just runtime licenses, not source. I've sold some source code licenses, but mostly I've sold runtime licenses, right? So you've got a customer saying, well, I'm betting my ETL subsystem, which is getting more and more important, on a piece of C++, that if it goes bang, I don't have the source code for it, I've got to call you, right? And yeah, I could buy the source code and then train the programmers, but it's kind of having the SQL, that's better than having the C++, right? And there's a number of customers who are in that position saying, I'd rather have the SQL in front of me than be relying on C++, right? Fine. And it takes a longer to develop. So I just wanted you to know that. So what are the productivity profiles? Okay. So the standard productivity profile that I was using when I was working with Sean Kelly and Associates was 1,000 fields a month being mapped from ERP billing systems wherever across to our data models, right? Now remember, in those cases, we already had our data models and we were altering data models we were not inventing new data models, right? So if you're inventing new data models, you should expect a degradation on that mapping performance. If you're using our data models, BI for all, for years and years, the productivity profile with working with Sean was 1,000 fields per month mapped. Now, when we went to years ago, we went to Carphone Warehouse and we said we can map 1,000 fields a month from your billing system across to our data models. They were like, yeah, right. Like, really, yeah, right. These guys, and the guy you can ask is Brian Ganley. I mean, these guys were very good at their data warehousing projects, and like 1,000 fields a month for mappings, no, that's not going to happen, right? That's not going to happen. But that's what we were doing, and we did that on that project. And on that project, Brian had gone public and said that we were 5 times faster than any other project that they had ever done to date, right? The ETL development profile was 5 times faster. Now we also then migrated those into Informatica. We migrated the SeETL mappings into Informatica mappings. They went live with Informatica. Nothing of SeETL left, right? That's often how we did our projects. We built the prototypes using SeETL. We got everything agreed. We built the reports. We had everything ready to go live. And then in about a 2 to 3 week period, we'd migrate all the ETL across to DataStage or Informatica, and then the customer would go live on that. And we had a way of migrating and balancing and making sure that the Informatica or DataStage mappings worked, right? And replicated what we had. So 1,000 fields a month mapping, where somebody can map, literally have a source system with, say, a set of source systems with, say, 4,000 fields in them, get that mapped to a data warehouse in 4 work months. That was the productivity profile that we were using back then, right? Now that productivity profile literally was 4 or 5 times faster than what was normal, right? 1,000 fields a month is very quick. Now we've invented a new thing which I hadn't intended to release, but I am going to release, which is a thing we call pre-mappings. And pre-mappings, we're seeing productivity benefits between 6 and 8. I mean, it's hard to nail down because, when you have such high productivity levels, it doesn't take much to disrupt them. So we're seeing productivity levels kind of between 6 and 8 times the 1,000 fields a month. Okay? So for an ERP, we say you should now be looking for somewhere between 6,000 and 8,000 fields a month mapped from your ERP across to our data models using SeETL, which means, for all intents and purposes, ETL development has become, in the scope of the overall project, ETL development has pretty much become free, right? That's kind of the promise of this. Now, when I say 6 to 8,000 fields a month, I'm talking about going into production with the C++ version. Okay? If you're going to go into production with the SQL generation version, you should cut that in half. Okay? Cut it in half. So instead of 6 to 8,000, you should be thinking 3 to 4,000 fields mapped per month, given that you want to build multiple levels of summaries and multiple levels of dimension tables and all that stuff. Because the big difference between the C++ version and the SQL version is the C++ version is inherently aware and was written from day one to be aware of multiple levels in dimension tables and to be aware of multi-level summaries. So there's no extra programming in the C++ version. There's no extra work, no extra programming for having multiple levels of dimension tables like day, week, month, quarter, year, and no extra work for having, daily transactions, weekly summary, monthly summary, by product category, subcategory, region, state, all these sorts of things. All these things where you are consistently or over and over again summarizing information. The C++ engine was built to inherently understand all that and require no extra work to implement it, right? So if you build a data warehouse and it's got no multi-level summaries in it, no multi-level dimension tables, everything's a flat, absolute flat data warehouse. You only have transactions, you only have detailed level dimension tables, then the productivity profile is the same. It's identical, right? But I've never implemented a data warehouse like that. I've always implemented multiple levels of dimensions, multiple levels of summarization, etc. And in the SQL version, you have to do development work to implement those things. There's actual development work for each level of dimension table and for each level of summary. In the SQL version, there's development work for that, right? And the reason is the SQL language is simply not powerful enough to be able to generate code to handle all that. Whereas when you're inside a C++ program, you have literally unlimited power to do whatever you want, okay, in terms of data manipulation. Literally, C++, there's no limits on what it is that you can do. So all these things to manage multiple levels of summary and all this sort of stuff were built into the C++ engine from day one. And as much as I would like to do it, it's not possible, I don't think, it's not possible to do it in the SQL generation version. Now that I've put the software out there for free, the source code, hey, maybe one of you geniuses out there, maybe one of you Einsteins can figure out how to do that, right? And have the time and the patience to figure out how to do that. Maybe, okay? So today, in terms of productivity, we're looking at between 6,000 and 8,000 fields you can map from ERP systems and etc. across to your data warehouse per work month. And on top of that, no extra time for multiple levels of dimensions, no extra time for multiple levels of summaries. That's all managed within the C++ engine. You can do that today. It's not a problem at all. Okay? 6,000 to 8,000. Now, that's for your productivity benefit. What about your runtimes and things like this? Well, one of the things about the SeETL C++ engine is it was written to be very, very efficient at what it was doing, because, quite frankly, in the 90s, our machines were much more expensive and much slower, right? Now here we are 20 years later. Then it was COBOL converted to C++. In C++ in 2003, we were making sure it was very efficient of resources, because the customers I was going after back then were telephone companies, right? The first two big development projects for SeETL were Saudi Telecom and Orange Telecom Romania, okay? And we had to put their volumes through the SeETL product in order to build the prototype. So there was a big emphasis on efficiency and performance. And that emphasis on efficiency and performance, you wind the clock forward 15 years, and you have the sort of CPUs that we have now, okay? And everything's being done, you have the faster memory, but literally you have the CPUs you have now. I mean, SeETL runs really quickly on these new Xeon 12-core CPUs. And also in the processing of fact records, because we were working at telephone companies, we would break up the fact records and process them in parallel, and we are able to process as many input files as we like in parallel with no extra consumption of memory. So we made, back in 2003, I implemented memory mapped I/O, and we made SeETL linearly scalable. You add more CPUs, you don't have to add any more memory. And it just goes faster. You put more CPUs in that thing, it just goes faster. And what we found was We could run 2 attribution processes per CPU on Windows, and 4 attribution processes per CPU on Unix machines. And so, if you have now a 12-core Xeon processor, you can run 24 attribution processes simultaneously on Windows, and boom, just straight through it will go. You don't have to run those through serially. So it's very fast in that respect. Now, it's not as fast as having the data always in the database, because you do need to bring the data out of the database, process it, and push it back through, right? Doing everything in the database is faster if you've got a fast database. Okay? So there are some people who look at who want flat data warehouses, no summaries, who want to do everything in the database and say, yeah, well, we'll do it in SQL, not in your C++ engine. There's that balance, right? Yes, it takes longer to develop, but not much longer. And yes, it'll go faster if the data never comes out of the database, right? So there's a little bit of that going on. So if you can map 6,000 to 8,000 fields a month through SeETL, why would you be doing anything else? So back onto performance, SeETL, given that it can run 2 processes per CPU per core on Windows, 4 on Unix, it's really fast at the attribution processing. Now the other last thing is we have a scheduler. One of my customers asked me to write a scheduler. I never did want to write a scheduler, but in the end I wrote one anyway. The scheduler is really good at being able to balance workloads. So what you can do within the scheduler is you can take lots of processes, lots of small processes, put them into groups, and then run the groups in parallel, and the scheduler will run all that in parallel, come to a synchronization point, then branch out and run things again. And we have found consistently that when we use our scheduler to run data stage jobs, like literally we can use our scheduler to run data stage jobs, we can run data stage jobs faster than the data stage scheduler can run those jobs. So our scheduler has this ability to balance the workload in the ETL subsystem. And that's kind of really nice, because your ETL batch window is one of the issues. People want that batch window to be as small as possible. They want to start the ETL as late as possible and deliver it by start of business, wherever the start of business might be. And that batch window is crammed, let's say, particularly for large companies. Okay? So there's speed of development, speed of processing, and reliability of processing. SeETL doesn't crash, for example. You don't have memory problems because it doesn't use that much memory. SeETL just doesn't crash very often. The one crash it tends to have is the network card on the machine has a glitch, and the connections to the programs fail when the network card glitches, because the programs are connected to the database via ODBC, and that goes through the network card whether you like it or not, right? So the one crash that we've had a little bit of trouble with is the network card having some failure on it and resetting, and the programs in process failing when that happens. And all you do is restart the batch. Now the batch, the scheduler, has this feature called in-flight restarting. So if you have, let's say, 8 groups running, process groups running at the same time, and one of the 8 fail, then all the other 7 continue running. You go fix the problem for the one that failed. You go into the scheduler and say restart while the others are running, right? So there's still 7 process groups running. One failed. You fix the problem. You say restart into the scheduler. The scheduler will figure out what's running and what's failed, and it will restart the process group, the process and the process group that has failed. So we call that in-flight restarting, where you don't have to wait for something to end to restart it, and you don't have to make any adjustments to any schedules or anything else like that. You just tell it restart, and it figures out what it's supposed to do and restarts at a step restart level. And that's really fantastic. I mean, none of the other ETL tools do that sort of thing, right? So you get lower software development costs, you get improved speed of your ETL subsystem, and you get improved reliability of your ETL subsystem when you take your existing ETL system and migrate it across to SeETL in general, right? In general. If you have an ETL subsystem that is as fast and reliable as SeETL is in Data Stage Informatica or SSIS, you've done a really good job. Okay? If we can't make your ETL subsystem faster using SeETL, you have done a really good job. Because every time we go in and we look at ETL subsystems, we find a lot of time wasted in that overall batch. A lot of time the CPU is not running at very high utilization. Disk is not running at high utilization where it otherwise could be, right? We find quite a lot of that. Of course, the other thing too is now that you've got SeETL as a freebie, your ETL machine can be as many CPUs as you want, and you don't have to pay anything for the extra CPUs to speed up your ETL subsystem. And because SeETL is like linear, you add another CPU, it goes that much faster. You can just add CPUs or add cores, and your ETL subsystem is going to go faster. I mean, literally, just go out and buy a 12-core Xeon Windows 2016 machine, and that's going to be a really nice ETL machine, right? So that's basically what I wanted to talk about. What are the benefits of using SeETL over Informatica, Data Stage, SSIS? Speed of development, productivity profile of development, and of course maintenance. I mean development and maintenance. Speed of the ETL subsystem. If you can do your ETL as fast as we can do your ETL, you're doing a pretty damn good job. And 3, reliability of your ETL subsystem. SeETL just doesn't fail. I mean, literally, the software is very stable, individual components, so even during upgrades and things like that, most programs are not touched. If you use the SQL version in a massively parallel computer like the Netezza machine or Teradata or something else like that, and you're just generating SQL and putting the SQL into the machine, it virtually never fails. You have to have a database failure for that to fail. And you maintain your database properly, you don't have database failures. Databases are very super reliable today, right? So they are the big reasons why you might want to have a crack at using SeETL. And if you do, the links will be down below. Go download it, have a look at it, check out the demonstration databases, try it out, and see what you think. Okay? And if you like it, use it. If you don't like it, thank you very much for trying it. Really appreciate that. Now with that, ladies and gentlemen, I think that's enough for today's video, 23 minutes. I'd like to say thank you very much for listening, and bye for now.